Hi guys, welcome back to New Ask Practical Science. I'm Mr Ballaam, and today we're going to be looking at some predator-prey relationships. So this topic feeds into the interdependence topic that we've been looking at so far, where we've been looking at the interaction between various organisms in an environment. So today we're going to be looking at that interaction between predators and prey. So we're going to be looking at the numbers of those, how those numbers fluctuate, so how they go up and down over a period of time. So to do this, we are going to use predator-prey relationship graphs to look at how one species affects the numbers of another species within an ecosystem. So what we're going to do, we're going to be using inquiry processes to analyze. So we're going to be drawing conclusions from the predator-prey graph that we have here, and we're also going to be able to communicate. So we're going to construct explanations to justify our answers. So we're not just going to say it goes up and down over time. We're going to give some reasons for that. We're going to say, why is it going down during this period, or why is it going up? So with the activity sheet that you have, you should see a half filled in predator-prey graph. It looks something similar to what I've got here. So what we're looking at here, we're going to look at, already plotted on the graph, we have numbers of caribou in a certain area. So caribou are reindeers, and the area that we're looking at here is Quebec, which is in Canada. So far away from England, where it's nice and cold. So looking at the graph, the first thing that we do is we have to analyze what information have we already been given. What are we looking at? Rather than just jumping straight into putting extra information on the graph, let's have a look, take a second to actually really analyze what's on the graph. So first thing we're going to do, we're going to look at the two axes, so along the bottom and the y-axis going up the top on the side. So looking at the year, the first one that we're starting off is 2001. And we can see that it's increasing by 1 year every block on the graph. So 2001, 2002, 2003, all the way up to 2013 at the end. So next axis we're going to look at the y-axis, so going up along the side here. So you can see it's going up in tens, so it's going 0, 10, 20, 30, 40, all the way up to 90. With that, that's every big block is going up for 10, so every little line that you see going across in between therefore represents 1. So we're going to look at a predator-prey graph here. So obviously there is going to be two different organisms on there. So we've got the predator and the prey. So the prey in this instance is the caribou that we're looking at, so the reindeers look a little something like this, whereas those numbers are times 10,000. So when you are looking, for example, here, where the value is 50 for the caribou in 2001, that's not saying that there is 50 caribou. We are saying that there is, so it's 50 times 10,000, so you're looking at 500,000 caribou. So not 50, there's a lot more than 50, there's 500,000 when you're looking at caribou. However, when you are looking for the wolves, so when you're looking at the number there, that is actually times 100. So this way they've been able to put the value of the caribou and the wolves on the same axis. So the wolves, you times in that number by 100. So for example, if you had 50 again, for wolves, it wouldn't be 50. It's going to be more than 50. It's not going to be 500,000 like it was with the caribou. However, it will be 50 times the 100. So you are looking at 5,000. Okay, so guys, so now we have the task of actually plotting our points onto the graph. So on your activity sheet, that looks something similar to this. You have a table here with the data that we need to plot on this graph here. So once again, reading the data from the table, on the top we have the year, so 2001, 2, 3, 4, all the way up to 2013. And then also we do have the number of wolves in Quebec times 100. So once again, it's not saying that there's 47 there, there's 47 times 100. Likewise, with the second value here, 52, there's not 52, there's 52 times 100. So for example, 5,200 wolves. So what we're going to do, I'm going to use these figures from the table here, and we're then going to plot those onto the graph here. So for the first value that we have here in 2001, for the number of wolves is 47. So what we're going to do, I'm going to use my ruler to help me make sure that my lines and my points are going to be spot on near where the value they should be, because I often find it difficult as I'm going up one of the lines, my eyes often swap onto another line and then I end up putting the point in the wrong place. So to resolve that, I use a ruler, so I know that when I'm reading off a value, it's going to be all on the same line and it's going to be spot on. So for the first one, we're looking at 2001 here. So we're going to go off the middle line here. So 2001, there were 47 wolves in Quebec. So 47 times 100. So you're looking at 4,700. But on the graph, on our scale, it will still be 47. So 47, so if we're counting up to 47, obviously there's 40 here, 41, 42, 43, 44, 45, 46, 47. So it's going to be along this line here. And then to make sure that I've got it on the perfect line for 2001, I've got my ruler clearly placed in the middle of the 2001 value on that slightly thicker line. So what we're going to do, we're going to go all the way up to the value that we just said. So it was 47 is what we're looking for. So 45, 46, 47, and then we're going to put a nice big cross on that point. I'll make it slightly larger so it's a little bit clearer on the visualizer for you. So that's plot point number 1 completed. So now we're going to go on to 2002. So now we need to move a whole block over. So we're into the 2002 area. I'm going to go once again on this middle line, slightly thicker, where we're going to draw our point. So the point, so we get that nice and straight with a ruler, so it's going to be on the right line. So now we have 52 times 100 wolves. So we need to plot this number 52 here on the graph. So we're going to go up this midline again, reaching all the way up to, so we've got 50 is the value that we can see here. So 50, however, we want 52, so 51. 52 is going to be slightly above it, 2 boxes above to get that 52. So there's the first 2 values. So for the third value in 2003, once again, we're going to go right in the middle of the 2003 line on this slightly thicker line in the middle here. We're going to get our ruler to make sure we get that point on the correct line. Lovely. So 2003, we had 45. So now we need to go up to 45. So going all the way up here. So 45 is actually where this point here is already. So what we can do, we can add that point on in the same place, obviously using a cross. So you can clearly see there is a point there showing the number of wolves. So with these so far, I've plotted 3 of the points there. I have used crosses to be able to determine, as long as I've used a different color as well. So you can see here in the bottom, we have a key. So if it's got a square on the line, that's tracking the number of caribou, whereas I've done crosses. So on mine, the crosses will be the number of wolves. So you can use different shapes. You can use a triangle shape or a circle shape, perhaps, just something that's different from a square to make sure that you can easily see which line is which. So if you'd like to pause the video now and see if you can plot on the rest of these values here onto the graph. Once you've done that, using your trusted ruler, I want you to connect those points together, much like the caribou line is here. So connect those points together with a ruler and you should see a pattern going all the way from 2001 all the way over to 2013. So pause the video and have a go at plotting the rest of those points, just like I have here. Okay, so guys, hopefully you've plotted your points there, and they do look something very similar to what I've done here with my points. I say I have gone through and joined them all up with a ruler, so if you haven't done that yet, be sure to do that now. One of the things you'll notice is where my starting point, I haven't drawn a line from my first value down to 0. That's because there wasn't 0 caribou or 0 wolves at the start of 2001, so we're not going to draw a line starting from 0 at the bottom. It is going to start from your first value here in 2001. So looking at the trends here, we can see, kind of in layman's terms, to put it simply, it goes up a little bit, and then it comes kind of towering down between 2003 and 2005. During that period, the number of wolves starts to increase by 2006, increases again by 2007, increases again by 2008, but not as much of an increase here, because we've gone from all the way down here to up here, quite a big increase, where it's only slowly increased up here along this line here. Then you notice between 2008 and 2009, there's quite a huge drop off here, going all the way down to a value here where you're looking at, what was that, 21? So 2,100 wolves down here, reduces a little bit more in 2010. The population then recovers by 2011, goes all the way back up here. Once again, it increases again in 2012 to get to this point up here, and then it slowly starts to come down again by 2013. So quite a lot of change there over the 2001 to 2013 data that we have here. So looking at those, so kind of looking at the trends, which is trends of it seems to be going down, and then once it's gone down to a certain level, it seems to recover and shoot back up again. And once again, this cycle, it goes down and then it shoots back up again. So it's this cycle of it going up and down with a number of wolves. So now looking at the data that was already on the graph, so the number of caribou, so the ones that are on the squares, so this line here, looking at the trend there, what seems to happen there? So straight away, it drops down quite a lot. It then starts to increase. The population size recovers, so more and more caribou are being counted. And when they did this experiment, when they counted the number of caribou in the area in Quebec, so it recovered massively up in 2005. However, then 2006, that number's come down. 2007, it's come down a lot more. And then once again, 2008, it's reduced again. So then, however, by 2009 and 2010, it has recovered again. So the number of caribou has increased over those 2 years. Following on from this 2010 value here, we are then starting to go down again a bit more, and once again, down again. So hopefully you're seeing a bit of a pattern there as well. So the value seems to go down, then it goes up, and then it goes down again, and then it goes up, and then it goes down. So quite similar to the pattern that we had with the number of wolves, but ever so slightly different. So when the number of caribou is quite low, the number of wolves has increased. Where here, where we're looking from 2004, 2005, the number of caribou is really high. So you're looking up here at 800,000, 810,000 caribou, whereas the wolf numbers now are really low. So that's dropped down. So as the number of caribou is increased, the number of wolves decreased. And then as the number of caribou starts to fall, so coming down here from 2006 to 2007, 2008, during those years, the number of wolves increases. However, then once the wolf or the number of wolves starts to decrease, once again, the number of caribou starts to increase. So you can say that as one of the values goes up, so as the number of caribou goes down, the number of wolves go up. And you can see the same for the opposite way around. So as the number of wolves decrease, the number of caribou increases. So you're getting the highest point, so the highest number of caribou at the same time as you're getting the lowest number of wolves at the same time. So likewise, once again, you're getting the lowest point of caribou and the highest point of wolves. So this then repeats itself across this graph. So this is a very typical pattern that we do see with predator-prey relationships. What was that? It's very dramatic. So now, actually looking at the graph that we have here, obviously we've analysed each line individually. So we've looked at the caribou line, the population of caribou over time, and also the population of the wolves. So now what we're going to do, we're going to see how are those two linked together. So in this situation, I say it is a predator-prey graph. So that means that one of these is going to be the predator, one of those is going to be the prey. So looking at the numbers here, we're going to decide that the caribou is the prey and the wolves are going to be the predators, because the wolves are really well adapted to being predators. So they're really good at their job. They're really good at hunting the caribou because they're really fast. They have great stamina. They can go for miles and miles in a day. They can run for a really long time without getting tired. They have incredibly sharp teeth. So when they do catch the caribou, they will be able to kind of take them down. They'll be able to kill them. Likewise, they have sharp sharp claws. They have incredible eyesight and incredible smell, much better than what the eyesight and smell of humans is, easily 10 times or 100 times better on those. So essentially they're really, really good at seeing their prey in an environment. So really far away, they'll be able to detect them. Likewise, they've also got that really strong sense of smell, so they can essentially sniff out their predators, track them down, and catch them. Also, wolves tend to hunt in packs. So when they are hunting in a packs, it makes it a lot more likely for them to be able to take down a lot bigger animals than what they are. So if you look at the size of a caribou, so the size of a reindeer, compared to the size of a wolf, they are very different in size. However, with the wolves working together as a pack, they can take down prey a lot bigger than them. So when we are looking at the values here from going up and down, we're looking at the population numbers in relation for the predators and the prey. So we can see here that when there's a really high number of predators, there's not that much prey. Because that's saying that because there's a lot more predators here, there's a lot more wolves, they're going to be eating a lot more caribou because there's more of them. So, there's several thousand more wolves between these years. So you're going to look at the several thousand more wolves that need feeding. So they're going to eat more caribou. So that's going to cause the caribou numbers to decrease because they're getting eaten a lot more. However, this gets to a point where it's there's really low numbers of caribou here. So there's not enough food to go around to feed all the wolves. So what's going to happen? The wolves are probably going to starve. They're not going to be able to survive because they're not getting enough food. Basically, there's not enough food to share amongst all of these wolves. So what tends to happen is they start to starve and they die. So their numbers will then start to decrease. So as you can see here, from 2003 down to 2005, quite a sharp increase down there of wolves kind of dying off. So during that period, then that means there's now less wolves. So you have a large population of wolves, their numbers start decreasing because there's not enough food, they start to die off. That means that they aren't going to be killing as many or hunting and killing as many caribou. So that gives the caribou population a chance to increase because now there's less wolves eating less caribou. So that gives the caribou more chance to reproduce, to get their numbers a lot higher again. So this pattern is what you see here from 2002 all the way up to 2005 here. The number of caribou has increased massively as there is very few wolves to hunt them down, to kill them, to predate on them. So therefore, that's allowed the caribou numbers to increase massively. However, now there's lots and lots of caribou. So there's enough food to go around for loads and loads more wolves. So the wolves number starts to increase again because there's now a huge supply of caribou for the wolves to eat. You've got 810,000 up here at its peak. So there's loads and loads of food. So wolves, there's plenty to go around for all the wolves so they can hunt, kill, eat the caribou, reproduce and get their numbers going up a lot higher. So that's what you see here in 2006 and 2007. So with this increasing number of wolves again, this then means that the number of caribou starts to decrease because they're all being hunted and killed by the wolves. So this is obviously a cycle. This pattern goes on and on of getting really high prey numbers, so predators number increases as well. However, when there's loads of predators, like up here, here, and would be here, if it continued the data, you would see that because there's a high number of predators, that means the number of prey is going to reduce because there's more predators eating more food, so therefore there is going to be less prey around. So once they've kind of eaten a lot of the food there, eaten a lot of the prey, there's now not enough food, their number decreases. So because there's less predators, that means the prey can reproduce more, they're not getting killed as often, they're not getting hunted, so they then population size increases. So I say this is a constant cycle that goes on and on. So guys, we have just finished looking at predator-prey relationships, where we've finished off this graph that we started off here. So we've put the number of wolves on there, and we've really analysed that data as well. So analysed that data, we've drawn some conclusions from it. So we've looked at what the relationship is between the two, tying in with our wider topic of interdependence, of how these organisms are linked together. So we've also justified our explanations. We've given real-world scenarios of why this graph is the way that it is. So with that, thank you very much for watching. I've been Mr Ballaam. This is New As Practical Science. Hope to see you again soon.